Question number 37 is related to the topic quantum physics, which cover about Compton scattering. A photon scatters off an electron at rest. So we have an electron at rest here, and this is the target. And then there's a photon going this way, and then will hit the electron. So what could be the result? The result is that the electron will get some momentum, and then it will move in one direction, and then opposite to that direction, which is also on the other side of the horizontal line here, we can see that the photon also changes direction, and not only the direction itself but also the lambda. The lambda of the photon also changes as well, from the initial lambda to a final lambda. So we can see that there's a relationship between the change, the shift in the wavelength related with the cosine theta here. This angle here is called the scatter angle of the Compton scattering. Okay, and here me is the mass of the electron, c is the speed of light. So they ask for what is the scattering angle of the photon. So basically we can just use the formula from the Compton scattering to solve for it. So before we do the math here, let's just review really quickly about what is the Compton scattering. So basically you can see that we see light here as a particle as well. It's a photon, and photon is a very special particle that is massless. Okay, the mass is just equal to 0 for light. Okay, but it still have energy. Okay, and the energy of it will be defined by E equals to h the Planck. E equals to h times with f, the Planck constant, times with the frequency of the light itself. And then you can find the momentum equals to the E divided by the C. Okay, and then here you can see that sometimes you don't see they have frequency AF, but they write frequency as this one. It looks like a V, right? But it's actually not a V. It's something like this. Okay, it's just like really pointed at this end here is very pointed, and this one is called a nuit. Okay, a nu. Okay, a nuit. It just stands for frequency. Okay, so that's not a V, just pay attention. And then this is divided by C as well, and then we got this one just equals to the lambda. Okay, and then for the electron, we can see that here also the conservation of momentum is applied. So we can see that the initial one here should equal to this one plus with this one. That's why you can see that here everything is horizontal, but here we got an amount of them go up, and then there will be another amount of them going down. So that if we plus these two together, you know, based on the parallelogram method, right, you can see that it should be equals to the same initial momentum. Okay, and then basically we got the momentum for the scattered photon. It's just like the same equations here, but everything had to change to an F, right? That stands for the final. Okay, and then we can find the momentum of the electron just by got this one subtracted for this one, but also have to pay attention to the cosine, the angle as well. So then basically this is the equation that we can use to solve for this question. And then we can see that here they provide for us the wavelength shift already. Then you can compare this one half should equal to this one, right? Okay, so then from there we see that 1/2 should equal to 1 minus cosine of theta. Now we just need to solve for theta. So go theta, just move cosine theta to the other side, and then I will move that 1/2 to this side, right, to the other side. Then this one just equals to 1/2. Okay, so by now you can just like find the angle by find the inverse functions of cosine, like the arc cosine of that 1/2. Okay, or if you're familiar with the unit circle, you can remember that the horizontal here will represent for the cosine value, right? So if something is a half, this is a unit circle, which means the radius here should on equals to 1. So half of it should be here, and then you can see that that will be the angle, okay? This will be the angle. And you can see this is 1/2 here. This is also the height. So this is actually a equilateral angle, and this one should be the 60 degree. That's why the answer is 60, right?